Can the heat capacity of a gas be negative? Have you ever wondered if the heat capacity of a gas could actually be negative? It sounds strange, right? Heat capacity usually tells us how much heat energy is needed to change a gas's temperature. Typically, when we add heat to a gas, its temperature rises, leading to a positive heat capacity. But there are some unusual situations where this is not the case. In most everyday gases, heat capacity is positive. This means that if you heat the gas, it gets warmer. However, in specific systems, particularly those with long-range interactions, negative heat capacities can occur. For instance, consider a self-gravitating gas cloud. When this cloud radiates energy and loses heat, it can actually heat up instead of cooling down. This happens because the cloud contracts, and the gravitational potential energy transforms into thermal energy, resulting in a negative heat capacity. Mathematically, heat capacity is defined as the change in heat added to a system divided by the change in temperature. When heat capacity is negative, it means that adding heat results in a decrease in temperature, or removing heat causes the temperature to rise. This behavior is quite different from what we usually expect in thermodynamics. In typical scenarios involving ideal gases, negative heat capacity is not observed. However, theoretical studies suggest that under certain conditions, such as specific changes in volume and pressure, the effective heat capacity can become negative. This phenomenon is more of a theoretical curiosity than something we see frequently in practice. To summarize, in normal gases, heat capacity is positive. But in special systems with long-range interactions, like gravitational systems, negative heat capacities can happen. This means that energy loss can lead to an increase in temperature, which is quite counterintuitive. Understanding these exceptions helps us appreciate the principles of thermodynamics in a broader context, revealing how they apply in various and sometimes surprising situations.